IUPAC stands for International Union of Pure and Applied Chemistry, which is the international common language used to name organic compounds. Just like how a movie series has a prequel, the movie itself, and a sequel, every organic compound has three parts to its name: the prefix, parent chain, followed by the suffix. To write the name of an organic compound, step 1, write the parent chain first. The parent chain is basically the backbone of an organic compound, which is the longest carbon chain bearing the main functional group. When there is only one carbon atom present, the parent chain name will be called meth. And when there are two carbon atoms, it's called eth, followed by prop, bute, pent, hex, hept, oct, and so on. Step 2, add in the suffix. The suffix denotes the main functional group. The reason why I say main is because there could be more than one functional groups present within the same organic compound, and we will choose only the main one. To know which one is the main one, we need to look at the priority order of the functional groups. From this table, the carboxylic acid functional group has the highest priority, aka it has the highest rank out of all the functional groups, while nitro has the lowest priority. Thus, when an organic compound has both a carboxylic acid functional group and an alkene functional group, for example, we will choose the carboxylic acid functional group as our suffix because it has a higher priority or higher rank than the alkene functional group. Step 3. Add on the prefix. The prefix denotes the side groups sticking out of the parent chain or backbone, which are also known as substituent groups. To name the prefix, we number each side group according to their respective positions on the main carbon chain in alphabetical order where two or more substituents are present. When there are two or more of the same alkyl substituents, we use the prefixes di, tri, tetra, etc. to avoid having to repeat naming the alkyl groups. Let's take a look at this example. To examine this organic compound more specifically and easily, I'm going to draw out the full structural formula. Are you able to spot the parent chain or the backbone of this organic compound? Well, it's this part over here because it has the longest continuous carbon chain bearing the main functional group, which in this case is the COOH group, which is also known as the suffix. Don't worry, as I'll be covering more about the functional groups in the remaining sections of this video. Lastly, this will give rise to the prefix because it is the side group sticking out of the parent chain. Do note that hydrogen atoms are not considered as side groups. Hence, this molecule's name is 2-bromopentanoic acid. To sum up, when naming an organic compound, step 1, find and write down the parent chain. Step 2, find the main functional group and write down the suffix. Step 3, write the prefix according to the positions on the main carbon chain in alphabetical order. If there are repeated alkyl side groups, use prefixes like di, tri, etc. accordingly. With this, we are ready to go on to apply these 3 steps to name all the different types of organic compounds in our A-level syllabus. Firstly, we have alkanes. As the name suggests, all alkanes have the suffix "ane". There are 3 types of alkanes, namely straight chain alkanes, branch alkanes, and cyclic alkanes. Knowing the types of alkanes is important as it will influence how we will name an alkane. For straight chain alkanes, there's only the parent chain and the suffix, and there's no prefix because there are no side groups present. For this example, let's find the parent chain first. Since it has 3 carbon atoms as the longest chain, its parent chain is prop, and since it's an alkane, its suffix is "ane". And because there are no side groups sticking out of the parent chain, there is no prefix, so this organic compound is called propane. Next, for this organic compound, the parent chain, which is the longest carbon chain, has 6 carbon atoms, hence giving the parent chain name hex. And since it's an alkane, its suffix is "ane", and because there are no side groups, there is no prefix. So this organic compound is called hexane. For branch alkanes, there is the presence of side groups, which is why they are called branch alkanes. This means we will need to add in the prefix on top of the parent chain and suffix. For this organic compound, same thing, step 1, we locate the longest carbon parent chain first, which is this chain right here. Then, the longest chain has 3 carbon atoms, so its parent chain name is prop. Then step 2, we know that this is an alkane, so that its suffix is ane. Step 3, let's locate the side group and number it according to its position on the parent chain. To do that, we can number the carbon atoms on the parent chain. So we label 1, 2, and 3. Since the side group is at carbon position number 2 of the parent chain, and it only has one carbon atom present, the prefix will be named as 2-methyl. Take note that hyphens are used to separate a number and a word. Hence, combining the prefix, parent chain, and suffix, this organic compound is called 2-methylpropane. For the next example, step 1, let's first find the longest carbon parent chain, which is this chain with 4 carbon atoms here. Hence, our parent chain will be called bute. Then, step 2, since it's an alkane, the suffix will be called ane. Step 3, to locate the 2 side groups, we should label the carbon atoms in the parent chain. Since there are 2 identical methyl side groups at positions 2 and 3 of the parent chain, the prefix will be named as 2,3-dimethyl. Don't forget that the numbers are separated by commas, while a word and a number are separated by a hyphen. Hence, the name for this organic compound will be 2,3-dimethylbutane. For cyclic alkanes, as the word cyclic suggests, they are alkanes which are in an enclosed loop. The naming for cyclic alkanes are a little bit special. We just need to add in cyclo in between the prefix and the parent chain. So for example, for this organic compound, same thing, we still follow the 3 steps. Take note that this is in the skeletal formula. So step 1, find the longest carbon parent chain, which is this chain with 5 carbon atoms right here. Hence, its parent chain name will be pent. Then step 2, since it's an alkane, its suffix will be ane. Step 3, since this is a basic cyclic alkane with no side groups sticking out of the parent chain, there will be no prefix. But remember to add in the cyclo in front of the parent chain. Hence, this organic compound's name is cyclopentane. For this organic compound, there are 3 carbon atoms in the parent chain, so its parent chain name is a prop. Since it's a cycloalkane, its suffix is ane, and we add in a cyclo in front of the parent chain name. Lastly, there is a chlorine side group at the first carbon position of the parent chain. When there's only one side group attached in a cycloalkane, we automatically assign it to be attached to the first starting carbon atom of the parent chain. Hence, this organic compound is called 1-chlorocyclopropane, or just chlorocyclopropane is also accepted. For alkenes, they have the CC double bond functional group and the suffix -ene. There are 3 types of alkenes: straight chain alkenes, branch alkenes, and cyclic alkenes. For straight chain alkenes like this organic compound, since it's an alkene with 2 carbon atoms and there are no side groups, it's called ethene. If there are 3 carbon atoms with no side groups, it's called propene. But when there are 4 or more carbon atoms in the parent chain, the CC double bond could be in different positions. So for example, because there are 4 carbon atoms in the parent chain of these 2 organic compounds, they could be called butene. But we can differentiate them based on the positions of the CC double bond. For this one here, the CC double bond starts at the first carbon atom of the parent chain. So this molecule can be called but1ene. But for the other one, the CC double bond starts at the second carbon atom of the parent chain. Hence, this molecule is called but2ene. But what if there are 2 or more CC double bonds present within the same organic compound, like this one? Before I explain, I'm gonna draw out the full structural formula so that we can examine the molecule with greater detail. In this case, same thing, step 1, we find out the number of carbon atoms in the parent chain, which is 4 carbon atoms. Then step 2, since it's an alkene, its suffix is -ene. Lastly, because the CC double bond is located at the first and third carbon atom of the parent chain, we will add in the number of their positions. And because there are 2 of the same CC double bond, we'll add in di. Hence, this molecule will be called buta-1,3-diene. For branch alkanes, like this one, step 1, we find the longest carbon parent chain first. In this case, it's this chain here with 3 carbon atoms, or it also can be this chain here, because if you think about it, actually both cases are the same. So after combining it with the suffix, we will get propene. Now on to adding the prefix. There is a methyl side group sticking out of the second carbon atom of the parent chain. Hence, we can add in the prefix 2-methyl, calling this molecule 2-methylpropene. For this organic compound, step 1, find the longest carbon parent chain, which in this case is 6 carbon atoms, and combining the parent chain at suffix only, it will be called hexene. But notice that the CC double bond here is not at the first carbon position of the parent chain, but at the second carbon of the parent chain. Hence, it should be called hex2-ene instead. Lastly, we can add in the prefix. So we have 2 exact same methyl side groups sticking out of the 4th and the 5th carbon atoms of the parent chain. So the molecule will be called 4,5-dimethyl-hex2-ene. For cyclic alkenes, just like cyclic alkanes, we just need to add in the word cyclo in between the prefix and the parent chain. So for example, for this organic compound here, there are 6 carbon atoms with no side groups sticking out. So it will be called cyclohexene. Let's take a look at one last example. Step 1. Let's find the longest carbon parent chain, which is the 5 carbon atoms in this enclosed pentagon chain right here. And the number starts off with the carbon in the CC double bond attached to the side group. So the parent plus suffix will be called cyclopentene. Take note that the numbering of carbon atoms in this case will be in the anti-clockwise direction and not the other way around, because the second carbon atom must follow the CC double bond. Lastly, because there are 2 identical methyl side groups sticking out at positions 1 and 4 relative to the CC functional group, the prefix is called 1,4-dimethyl. So this organic compound is called 1,4-dimethyl-cyclopentene. For arenes, they have this hexagonal ring structure with a circle inside called a benzene ring, and arenes usually have the suffix benzene. There are 4 types of scenarios that we need to know when it comes to naming arenes, namely monosubstituted benzenes, disubstituted benzenes, polysubstituted benzenes, and when the benzene ring is treated as a substituent group. For monosubstituted benzenes, meaning they only have one substituent group sticking out of the benzene ring, the name of the substituent group is added as a prefix to the word benzene. For example, if a methyl group is the substituent, the organic compound is called methylbenzene. And if the substituent group is an ethyl group, the organic compound is called ethylbenzene. Similarly, if the substituents are nitrogen dioxide and chlorine, the compounds are called nitrobenzene and chlorobenzene respectively. However, there are other monosubstituted benzenes that have special names assigned to them and don't follow the benzene suffix because, well, they are that special. Examples include benzaldehyde, phenol, phenylamine, and benzoic acid. Moving on to disubstituted benzenes, meaning there are 2 substituent groups, the general rules are: number 1, numbers are used to indicate the relative positions of the 2 substituents. For example, in this case, it's called 1,2-dibromobenzene, and this is called 1,3-dibromobenzene, and this is called 1,4-dichlorobenzene. Rule number 2. If the 2 substituent groups are different, name the 2 different groups in alphabetical order. For example, the 2 substituent groups in this compound are bromine and methyl. Since bromine starts with a B, it comes first and methyl will come after. So, carbon atom on the benzene ring that bromine is attached to will be labeled as carbon atom number 1, and the carbon atom on the benzene ring attached to the methyl group will be labeled as number 2. Hence, this organic compound will be called 1-bromo-2-methylbenzene. Let's take a look at another example. The 2 substituent groups here are methyl and nitro groups. Since M comes before N, this substance will be called 1-methyl-3-nitrobenzene. And for rule number 3, if one of the 2 substituents is the kind that gives a special name to the molecule, then the compound will be named as a derivative of that special compound. If both substituents give derivatives with special names, then the preference is given to the substituent of the highest nomenclature priority. Examples include 2-bromophenol, 3-hydroxybenzoic acid, and 4-nitrobenzaldehyde. For polysubstituted benzenes, meaning if there are 3 or more groups attached to the benzene ring, the numbering is in such a way so as to keep the prefix numbers as low as possible and with preference given to the group of highest nomenclature priority, which is reflected in this table here, and I've also shown this at the earlier part of this video. So for this organic compound here, there are 2 bromo substituent groups and 1 methyl substituent group. And according to the nomenclature priority, methyl is of a higher priority or higher rank than the bromo substituent group. The carbon atom on the benzene ring that is attached to the methyl will be labelled as position number 1. Then these will be positions 2 and 4. So this organic compound is called 2,4-dibromo-1-methylbenzene or just 2,4-dibromomethylbenzene. If one of the substituent groups present gives rise to a compound with a special name, then only 2 positions are mentioned. For example, the 3 substituents in this case are OH, Cl, and NO2. But since we know that the OH group will give rise to the special name of phenol, the suffix will be called phenol instead. Hence, the carbon atom on the benzene ring that's attached to the OH group will be given the carbon position 1. Then, the chlorine side group will be attached to carbon position number 2 and the nitro group will be attached to position number 4. Hence, this organic compound will be called 2-chloro-4-nitrophenol. Lastly, the benzene ring could act as a substituent group or become the prefix instead of the suffix. During such a scenario, the benzene ring will be called a phenyl group. This happens when, number 1, the substituent on the benzene ring has more than 6 carbon atoms, or number 2, the highest priority functional group is a substituent on the side group of the benzene ring. For example, this organic compound here has a substituent on the benzene ring that has more than 6 carbon atoms. So the benzene ring will now become a side group instead. So we will follow the usual 3-step rule to construct its name. Firstly, find the longest parent chain, which is this chain here with 7 carbon atoms. So its parent chain plus suffix will be called heptane. Now to write in the prefix, we will number the first carbon atom on the parent chain from this side as it is closest to a side group, and so on. So now the side groups are the phenyl group and the methyl group. And because we need to arrange them in alphabetical order, the letter M in methyl comes before the letter P in phenyl, so the prefix will be called 5-methyl-2-phenyl. Combining everything together, this organic compound's name is 5-methyl-2-phenyl heptane. Let's take a look at one last example. There are 2 functional groups here, the benzene ring and the alcohol OH functional group. Based on the table of functional group priority, the alcohol functional group has a higher priority than the benzene ring functional group. And since the higher priority alcohol functional group is a substituent on the side group of the benzene ring, the parent chain and suffix combined will be called ethanol. So the carbon atom here that is attached to the alcohol functional group will be labelled as 1 and so on. And since the benzene side group is attached to the second carbon atom of the parent chain, the prefix is called 2-phenyl. Combining everything together, this organic compound has the name of 2-phenyl ethanol. In this section, we will be covering the nomenclature on naming for halogenoalkanes. As the name suggests, halogenoalkanes are derived from their corresponding alkanes, so it's just halogens, which are group 17 atoms like fluorine, chlorine, and bromine, that will be attached as side groups to the alkane parent chain. Let me take you through the first example. Step 1. Find the longest parent chain. In this case, it's this chain here with 2 carbon atoms, so its parent chain is called F. Step 2. Since it's an alkane, the suffix is ane. Lastly, let's write in the prefix. As there is only 1 chlorine group sticking out, the suffix will be called chloro. And combining everything together, the name for this organic compound is chloroethane. Next, step 1. The longest parent chain in this case is this one here with 3 carbon atoms. And since it's an alkane, the parent chain plus suffix is called propane. Lastly, for the prefix, since there are two identical bromine side groups on the first and third carbon positions of the parent chain, the prefix will be called 1,3-dibromo. And combining everything together, we will have 1,3-dibromopropane. Let's take a look at this organic compound. If you want to examine this molecule in further detail, you can draw out the full structural formula just like this. Notice that it has the CC double bond, meaning it's an alkene. But same thing, let's first find out the longest carbon parent chain, which is this one here with 5 carbon atoms. Then, because the CC double bond carbon atom starts at the second carbon atom position, hence the parent chain plus suffix will be called pen2-ene. Lastly, for the prefix, since the iodine atom is attached to the fourth carbon atom of the parent chain, this organic compound will be called 4-iodopen2-ene. For the last example here, it's the exact same as what we've learned in alkanes in the earlier section of this video. Since it's a cyclic alkane with 5 carbon atoms and a bromine side group sticking out, it's called bromocyclopentane. For alcohols, are also known as hydroxy compounds, they have the suffix -ol. With the 3 steps that we've learned in the basics in IUPAC naming in the earlier section of this video, let's name a few hydroxy compounds. For this one here, since the parent chain has 2 carbon atoms, and it is an alcohol with no side groups, it's called ethanol. Next, there are 3 carbon atoms in the parent chain here, but the OH group is attached to the second carbon atom of the parent chain. Hence, we will name this propan2-ol. For this organic compound, the parent chain is this one here with 3 carbon atoms. There are 2 side groups. Can you spot them? Well, it's actually this methyl group here and OH group. So since both of these groups are attached to the second carbon atom of the parent chain, the organic compound will be called 2-methylpropan2-ol. For this one, since it has 5 carbon atoms on the main chain and it's a cyclic compound, with the OH side group sticking out, it is called cyclopentanol. For aldehydes, they have the functional group CHO and it looks like this. As such, its suffix is called -al. There are 2 types of aldehydes, namely aliphatic aldehydes, which means that the parent carbon chain is open and not enclosed in a loop, and the other type is called aromatic aldehydes, where the CHO functional group is directly attached or bonded to a benzene ring, and its name will become benzaldehyde. For aliphatic aldehydes, if the CHO aldehyde functional group is the only functional group or the highest priority out of all the functional groups within the same organic compound, the carbon atom attached to the functional group will be labeled as the first starting carbon atom position of the parent chain. So for this organic compound, since it has only 1 carbon atom, it will be called methanol. And if an aldehyde has 2 carbon atoms, it will be called ethanol. If it has 3 carbon atoms, it will be called propanol, and so on. Let's take a look at this example. Are you able to construct the name for this organic compound? Well, step 1, locate the parent chain. So if you were to label 1, 2, 3, 4, we will find that this is the longest carbon parent chain with 4 carbon atoms. The 4th carbon atom being here or here doesn't really matter as they are the same thing if you think about it. So the parent chain plus suffix will be called butanol. Lastly, because there is a methyl side group attached to the 3rd carbon atom of the parent chain, its prefix is called 3-methyl. Combining everything together, we will have 3-methylbutanol. Last one before we move on to aromatic aldehydes, let's take a look at this organic compound. You may be wondering, isn't this an aromatic aldehyde? Well, actually it isn't, because the CHO functional group is not directly attached to the benzene ring. Remember that aromatic aldehydes or benzaldehydes occur only when the aldehyde functional group is attached directly to the benzene ring. So for this organic compound, let's first start by finding the longest parent carbon chain. There are 2 functional groups here, the aldehyde functional group and the benzene ring. And according to the table of nomenclature or functional group priority, aldehyde is of a higher priority. So our suffix will follow the aldehyde suffix and we can number the carbon atoms starting from the aldehyde functional group. So this will be our parent carbon chain with 3 carbon atoms. The benzene ring is a side group that is attached to the third carbon atom of the parent chain, and because the benzene ring is now a side group, the name of the benzene as a prefix will be called phenyl. So the name for this organic compound will be 3-phenylpropanol. For aromatic aldehydes, the CHO functional group is directly attached or bonded to a benzene ring, and its name will be called benzaldehyde. So for this example, since bromine is the side group that is attached to carbon position 4 of the parent chain of benzaldehyde, it will be called 4-bromobenzaldehyde. For ketones, it has the functional group of COCH3, and it looks like this. As such, it has the suffix -one. Similar to aldehydes, if the ketone functional group is the only functional group or the highest priority out of all the functional groups within the same organic compound, the carbon atom attached in the functional group will be labeled as the first starting carbon atom position of the parent chain. For this example, there are 3 carbon atoms in the parent chain, hence it will be called propanone. Likewise, if I were to add 1 more carbon atom, it will be called butanone. So if you realize, there is no such thing as methanone, as the ketone functional group already has 2 carbon atoms. So it's impossible to have only 1 carbon atom in a ketone. Now let's take a look at this example here. There are 6 carbon atoms in this enclosed ring here, so it's called cyclohexanone. For our last example, notice that we have 2 functional groups, benzene and ketone. Since ketone has a higher priority than benzene, benzene will act as a side group. So step 1, let's find our parent chain, which is this one here with 4 carbon atoms, with the first carbon atom starting from the ketone functional group. So the benzene side group is attached to carbon atom number 3 of the parent chain. Hence, this organic compound is called 3-phenylbutanone. For carboxylic acids, they have the suffix oic acid and looks like this. Remember that the carboxylic acid functional group has the highest priority out of all the functional groups. So it's also like saying it's the king of the functional group's kingdom. Hence, the numbering of the parent chain starts with the carboxyl carbon in any organic compound that contains the carboxylic acid functional group. So for example, for this carboxylic acid, it only has 1 carbon atom, with no other side groups or functional group. So its name is methanoic acid. And if we were to add 1 more carbon atom, it would be called ethanoic acid. Now let's add in side groups or functional groups. For this organic compound, there are 2 functional groups, namely the carboxylic acid functional group and the hydroxy or alcohol functional group. As the carboxylic acid functional group has the highest priority, the carbon atoms will be numbered starting from the carboxy carbon atom, like this. So there are 3 carbon atoms in the parent chain. So the parent chain plus the suffix will give you propanoic acid. Lastly, for the prefix, since the hydroxy side group is attached to the second carbon of the parent chain, the prefix will be called 2-hydroxy. Combining everything together, this organic compound will be called 2-hydroxypropanoic acid. And just in case if you've forgotten, when 2 carboxylic acid groups are present, the suffix dioic acid is used. So for this case, there are 3 carbon atoms present and also 2 carboxylic acid functional groups present. It will be called propane dioic acid. Lastly, just before we move on to the next section, are you able to construct the name for this organic compound? While it may seem very complicated, don't panic and just follow my 3 steps that I've taught you. So step 1, find and write down the parent chain. We can start off by numbering from the carboxy carbon atom, and we will find that there are 3 carbon atoms in the parent chain. So we know that our parent chain name will be called propan, and our suffix name will be called oic acid. And since the CC alkene double bond begins at the second carbon atom of the parent chain, this organic molecule will be called prop-2-enoic acid, or just propanoic acid is also accepted. Now, let's begin on the section of acyl chlorides. Acyl chlorides are basically derivatives of carboxylic acids, which we've learned in the previous section. The difference is that instead of the suffix oic acid, the suffix will be YL chloride. and the functional group will look like this, simply by replacing the OH group with a chlorine atom. For example, this organic compound is called ethanoic acid, but once I replace the OH group with a chlorine atom and the carboxylic acid becomes an acyl chloride, it will be called ethanoyl chloride. Likewise, this molecule is called benzoic acid, but once I replace the OH group with a chlorine, its name will become benzoyl chloride. For esters, they have the functional group COO and has the suffix -ate. Esters are formed from the reaction between a carboxylic acid or acyl chloride with an alcohol or hydroxy compound. Esters have two parts to its name. For example, ethyl, ethanoate. So ethyl is the first part while ethanoate is the second part. To name esters, the general rule is that the first part of its name is named after the right section of the ester or the right of the COO ester functional group, while the second part of its name is named after the left section of the ester. So it's like crossing over to match each section of the organic compound to each part of the name. For example, let's take a look at this ester. In the right hand side section of this ester, there are 3 carbon atoms, hence making the first part of its name propyl. Then to name the second part of its name, we will look at the left hand side section of the ester and there are 2 carbon atoms, meaning the second part of a name will be called ethanoate. So combining them, we will get propyl ethanoate. Let's take a look at another example. To write the first part of a name, we look at the right section of the organic compound. So in this case, there's 4 carbon atoms, so the first part of the name will be called butyl. For the second part of the name, we look at the left section of the organic compound. It has 3 carbon atoms, so it will be called propanoate. So combining everything together, its name is butyl propanoate. For this section, we are going to cover amines. As the word suggests, its suffix is called amine. Amines are nitrogen compounds, which means that they contain a nitrogen atom. Depending on the number of alkyl or aryl groups attached to this nitrogen atom, we can classify amines into primary, secondary, or tertiary amines. A primary amine will have 1 R group attached to the nitrogen atom, while a secondary amine will have 2 R groups attached, and likewise for tertiary amines, there will be 3 R groups attached. Knowing the type of amine is extremely important as it will influence how we name them. When naming all 3 types of amines in general, there are 3 important rules that we need to follow. Number 1, the names of the alkyl, aryl, or R groups attached to the nitrogen atom are given first as the prefix, followed by the suffix amine. But if the nitrogen atom is directly attached to the benzene ring, it becomes an aromatic amine which will have the suffix phenylamine instead. For secondary amines, we add the prefix N- to denote that it is a secondary amine. And we add the prefix N, N- to denote that this amine is a tertiary amine. So primary amines will not have the N- prefix at the front of its name. However, if there are repeated R groups or the R groups are identical, there is no need to put the N- prefix and we can just use the prefix di, tri, etc. Number 3, if there are 2 functional groups that are of higher priority than the amine group, the amine group will then become the substituent or side group and be called the amino group instead. For this amine, it has 1 carbon atom and there is only the amine group, so it will be called methylamine. For this, it has 2 carbon atoms with the amine group and hence it is called ethylamine. Now let's take a look at this example. If you were to observe carefully, there are 2 alkyl groups attached to the nitrogen atom. This means that this is a secondary amine. To name this organic compound, we first name the groups attached to the nitrogen atom. In this case, there are the ethyl and methyl groups attached to the nitrogen atom. Since the E in ethyl comes before M in methyl, the prefix will be called ethyl-methyl as we need to arrange it in alphabetical order. And don't forget, because it is a secondary amine, we will need to add in the N- at the front of the amine as part of the prefix. Combining everything together, it will be called N-ethyl-methylamine. Next, for this molecule, Notice that there are 3 alkyl groups attached to the nitrogen atom, which makes it a tertiary amine. Since each alkyl group attached to the nitrogen atom are all identical methyl groups, the prefix will be called trimethyl, and there will be no need to include the NN in the prefix because the groups are the same. And since its suffix is amine, its name will be trimethylamine. Next, for this, there are 3 alkyl groups attached to the nitrogen atom, making it a tertiary amine. We have an ethyl group and 2 identical methyl groups attached to the nitrogen atom, so the prefix will be NN-dimethylethyl. Hence, the full name will be NN-dimethylphenyl. Hence, the full name will be NN-dimethylethylamine. For this molecule, there are 2 carbon atoms and 2 identical amine groups, so the suffix will be diamine. And because the 2 amine groups are attached to the carbons 1 and 2, the prefix will be called ethane 1,2. So together, it will be called ethane 1,2-diamine. Now let's take a look at this interesting organic compound. Some of you may be wondering, is this a phenylamine? Well, the answer is no, because the nitrogen atom is not directly attached to the benzene ring, as the nitrogen atom and benzene ring are separated by a CH2 group. So the name for this organic compound will be phenylmethylamine and not methylphenylamine because it's not a phenylamine. For this example, it is an aromatic amine, or phenylamine because the nitrogen atom is directly attached to the benzene ring. So this carbon atom on the benzene ring attached to the NH2 group will be labeled as the first carbon atom, and the second carbon atom will be the one attached to the methyl side group. Hence, this is called 2-methylphenylamine. Next, there are 2 groups which are directly attached to the nitrogen atom of this organic compound, making it a secondary amine. The 2 groups attached are the benzene ring and the methyl group. Since the benzene ring is directly attached to the nitrogen atom, this makes the molecule a phenylamine. And since it is a secondary amine with the methyl group attached to the nitrogen atom, its prefix is called N-methyl. And together with the phenylamine suffix, its name will be N-methylphenylamine. For this organic compound, there are 2 identical benzene rings that are directly attached to the nitrogen atom. Hence, this will be called diphenylamine. For this, there are 3 groups directly attached to the nitrogen atom, making this a tertiary amine. Since it is a tertiary amine with a benzene ring and 2 identical methyl groups directly attached to the nitrogen atom, the prefix will be called NN-dimethyl. Combining it with the suffix, we will get NN-dimethylphenylamine. What about this organic compound here? While it may seem complicated, let's take it one step at a time. There are 2 functional groups here, the NH2 functional group and the COOH carboxylic acid functional group. But in this case, remember that the COOH carboxylic acid functional group is of a higher priority than the amine functional group, so the suffix will follow the carboxylic acid suffix. And since the parent chain has 3 carbon atoms, the parent chain name will be called propan. Lastly, for the prefix of the name, since the amine group is now a side group instead of the main functional group, and it is attached to the 3rd carbon atom of the parent chain, the prefix will be called 3-amino. Combining everything together, we will have 3-aminopropanoic acid. Let's take a look at one final example. Similar to the previous example, there are 2 functional groups present, namely the amine group and the alcohol functional group. Since the alcohol functional group has a higher priority than the amine functional group, the suffix for this organic compound will follow the alcohol suffix. Hence, the carbon atom attached to the OH alcohol group will be labeled as the first carbon atom, and the next carbon atom will be labeled as number 2. Since there are 2 carbon atoms, the parent chain name, together with the suffix, will be called ethanol. Lastly, for the prefix, the amine group is attached to the 2nd carbon atom and it is a side group and not the main functional group. Hence, the prefix will be called 2-amino. Combining everything together, we will get 2-aminoethanol. In this section, we are going to cover amides. Amides have the suffix amide and the functional group looks like this. There are three types of amides: primary amides, secondary amides, and tertiary amides. For primary amides, apart from the carbon atom, the nitrogen atom is attached to two hydrogen atoms. For secondary amides, the nitrogen atom is attached to one R group and one hydrogen atom. And for tertiary amides, the nitrogen atom is attached to two R groups and no hydrogen atoms. Similar to amines, for secondary amides, we need to add the N- prefix in front of the name and add the N, N- prefix for tertiary amides. That's it. To name amides, if it's a secondary or tertiary amide with R groups attached to the nitrogen atom, the name of these groups come first as part of the prefix. This is then followed by the parent chain and the suffix, which is called amide. For this organic compound, there are two hydrogen atoms and no R groups attached to the nitrogen atom. Hence, this is a primary amide. And since there is only one carbon atom, it will be called methanamide. If I were to add on one more carbon atom to the chain, with the nitrogen atom still attached to two hydrogen atoms and no R groups, it will be called ethanamide. Next, let's take a look at this example. Notice that there is one methyl group attached to the nitrogen atom, making this a secondary amide. Thus, we need to add in the N- prefix. Since there is only one methyl group attached to the nitrogen atom, so its prefix will be called N-methyl. After constructing the prefix, let's construct the next part of the name, which is the parent chain. Since there are three carbon atoms, counting from the carbon in the amide group, the parent chain name will be called propan. Take note that this carbon atom is not counted as it is directly attached to the nitrogen atom and it is not part of this consecutive carbon chain. And since it's an amide, it has a suffix amide, and combining everything together, its name will be called N-methylpropanamide. For this example, notice that there are two methyl groups attached to the nitrogen atom, making this a tertiary amide. Thus, its prefix will be called N-N-dimethyl. And since there are two carbon atoms in the parent chain, the parent chain name will be called ethan. Lastly, combining everything together with the amide suffix, its name will be N-N-dimethylethanamide. Let's take a look at one final example. As you can see, this is the amide group and it is directly attached to the benzene ring. Hence, this organic compound's name will be called benzamide. Last but not least, here are the practice questions as promised. Feel free to pause the video to try them out and the answers will be in the description below.